Okay, so this is homework number 15. Number 1 is asking for what is the total surface area of the rectangular prism. So we're looking for total surface area, which I highlighted there. So the first thing I'm going to do is write my formula for total surface area for a rectangular prism. We've already gone over that quite a bit. So that is P times H plus 2 times capital B. All right, so we're going to need the perimeter of the base, the area of the base, and then the height. Go ahead and we'll highlight the base that we're going to use, and in this case we're going to use the rectangle here. And then we'll go ahead and we'll draw this rectangle, redraw it, and we'll label it. So this is 2, 3, 2, and 3. So there you can use that to go ahead and get the 3 areas of stuff that we need. What we're also going to do is we're going to highlight the height of this prism. Oops, that's not the highlighter. We're going to highlight the height of the prism in green, which is 6. Alright, so number 2. What is the lateral surface area of the cylinder below? So again, we're looking for lateral surface area. So I know that I'm looking for lateral surface area of a cylinder. So the formula for lateral surface area of a cylinder is 2 times pi times the radius times the height. So like that's it. That's all we're doing. Okay, so let's go ahead and we'll highlight the radius that we have. Okay, which is the circle of the cylinder. And then we're going to highlight in green the height of this prism. Okay. It's going to be 8 3/5. All right. So we do know that we do need the radius. So if this is 2.5, so I'm just going to scratch that out. 2.5, that's a diameter. Whoops. Okay, that's a diameter. So we need the radius, which is half of that. So the radius is going to equal 1.25. All right. 8 3/5, you can go ahead and use the decimal of that, which is 8 and 8.6. All right, 8.6. Put a little equal sign there, just like that. And I'll highlight that also. Whoops, no. We'll just leave it. All right, there you go. Okay, number 3. Does the following graph represent a function? Okay, so I kind of drew in the graph for you a little bit better so you can see. So the red line is what we're looking for, is what we're looking at actually, to tell if it's a function or not a function. So yes or no. Okay, number 4. If you deposit $4,500 at 5% annual interest compounded annually, how much money will be in the account after 10 years? So we have an interest question. So is it simple or is it compounded? So right there it tells me that this is compounded. So if we know it's compounded, then we're going to use the compound formula, which will be A equals the principal multiplied by 1, the number 1, plus the interest rate, and then time is the exponent. So there you go. Okay, number 5 says that a sphere has a diameter of 4 3/4 inches. What is the volume of this sphere? So volume of this sphere right there tells me what we're looking for. The formula for volume of a sphere, remember, is V equals 4/3 times pi times the radius, and it's cubed, okay? So a diameter of 4 3/4, so we'll use 4.75. Okay. But we need the radius, so we have to divide that in half. When we divide 4.75 by 2, okay, to get the radius, we're going to get 2.3 0.75. So the radius is what we're going to use in the formula. Okay, there you go. Okay, number 6. So we're going to write an algebraic representation of the dilation shown below. So we're going to, what I kind of did is label them for you. For the smaller L, this is a measurement of 1, right? Oops, let me rewrite that. This is a measurement of 1. And then for the bigger L that we have here, that's a measurement of 2. So what you're going to have to figure out is the algebraic representation, x comma y changes to whatever goes there. Okay, it's getting, you need to find out if it's getting bigger or if it's getting smaller. Okay, so number 7, what is the total surface area of the triangular prism shown below? So total surface area, okay, I'm going to highlight that because that's what we're looking for. I know it's a triangular prism, so let's write our formula. PH plus 2B. So we're going to need the perimeter of the base, we're going to need the area of the base, and we're going to need the height of the prism. So let's go ahead and we'll start highlighting what we're going to use in this drawing that we have here. So I know that this is my base that I'm going to use. And so if that's my base, then this 14 measurement is going to be my height. So now let's redraw the base that I have. So I'm going to redraw that. Let me get, okay. I'll redraw it out here. So we have a measurement of 10, measurement of 13, 13, and then this one down here is going to be 12. Whoops. All right, here's my 90-degree angle there for you. Okay, number 8. Solve the following equation for x. So I have 2 and then parentheses 3x minus 1 plus 2 parentheses 4x plus 5 equals 8. So this is going to be a real long thing after I distribute what's going on in here. Actually, let me use the pointer for you. What's going on right here, and then what's going on right there. Okay, so let's go ahead and start working that out. We have to multiply 2 times 3 and also 2 times negative 1. So 2 times 3x is going to give me 6x. 2 times negative 1 is going to be minus 2. Now I need to distribute 2 times 4x and 2 times plus 5. So 2 times 4x is plus 8x, and then 2 times 5 obviously is plus 10. So there we go, to equal 8, and then you can combine like terms and then solve for x. Okay, number 9, says to write an algebraic representation of a reflection across the x-axis. So I'm going to highlight that for you. That's what we're looking for. Okay. What I went ahead and did from the note page that you have on y'all's desks, I went ahead, if I can get it, and zoom that in for you. So this is a reflection across the x-axis. So you're going to have to write the algebraic representation. X comma y. And you need to have, what's going to change? The opposite of x or the opposite of y? Okay, only one of those is going to change. So figure out what it is and fill in the rest of it. Okay, number 10. Order the following numbers in descending order. Okay, descending order. That means we're going down. So we're going to go from the greatest to the least.